Okay, so as Dawn said, I'm going to be presenting perspectives from the Monterey Bay Marine GIS User Group on opportunities for improvement in GIS. And just to give you a little background before I move forward, essentially our user group was started in January of this year and is co-organized with Nadine Golden from USGS, who's here today. And essentially we started this to foster collaboration between all the different federal, state, and local agencies, NGOs, and all the different marine labs within Monterey Bay. And our overall goal was to support GIS training within our community. And we've done this through several different meetings where we've hosted invited speakers, including Don Wright and Patrick Halpin. We also hosted an MGET workshop that Jason Roberts led down at CSUMB. So we've got approximately 100 members in our user group, and we solicited input from all of our members to sort of provide feedback today at the Ocean Summit. So this is an outline of my presentation, and it's going to be very applied in nature, and I'm just going to touch on the marine GIS challenges and opportunities for improvement, both from our user group and then also at the NOAA Fisheries Lab and USGS labs in Santa Cruz. So at our inaugural meeting in January at the user group, human dimensions data sets was identified as a significant data gap, not only in Monterey Bay, but also in the marine environment in general. And this is really important information to start integrating into a GIS framework. Ben Halpern gave a lot of great examples for applying these types of data for coastal and marine spatial planning. And so these data sets are a priority. So what we see as opportunities for improvement are expanding human dimensions and really integrating that into the ArcMarine database structure, and then also supporting GIS tool development that really helps us to collect, analyze, synthesize, and bring together these different cultural and socioeconomic data sets. And some great examples of some tools that have recently come out are the C-Sketch tool out of the McClintock lab at UCSB, and also the eCatch tool that the Nature Conservancy uses. Another main point that's been hit earlier in this panel is expanding 3D and 4D capabilities. So marine organisms are highly dynamic. They're using the entire water column. They're moving across these oceanographic fronts that are changing over time. So it's really important that we support geoprocessing and mapping to include this dynamic movement in space and time within the GIS. Another point is sharing these dynamic maps in real time. And a great example of this is out of the Northeast Fisheries Science Center of NOAA. This map here is a screen capture of a map that's served online to update boats in Cape Cod on these dynamic management areas for right whales. So this is a great example, and we also see this as an opportunity for ESRI to really increase their capabilities for distributing these dynamic maps through ArcGIS Online, ESRI mobile applications, or other ways. At the NOAA Fisheries Lab in Santa Cruz, we're collecting a wealth of information using visual survey techniques such as remotely operated vehicles, manned submersibles, and in collaboration with USGS doing towed camera sleds. So this map here shows the spatial location of all of our different visual surveys throughout the Southern California Bight. So this generates a wealth of georeference data on fish and macroinvertebrate distribution and abundance. And so that really represents a challenge as far as the workflow and managing those data sets. This image here shows a schematic of our data workflow. And so to integrate, manage, and process all of these large data sets from these visual surveys, we're moving between many different types of software and tools to accomplish that. So if this could be more streamlined, that would be a great opportunity. So with that in mind, linking tools, useful tools and extensions into the ArcMarine geodatabase structure and feature classes would be a great step to help support that, to support the data processing and data analysis that we're doing. And we would also provide the users and our community with a greater rationale for adopting the ArcMarine geodatabase model and this standard also will help streamline workflow. A great example that's been brought up earlier is the ARC Hydro data model that integrates a lot of useful tools into that. At the Santa Cruz lab, USGS is collecting a wealth of seafloor data information and ground truthing information in collaboration with CSUMB, Seafloor Mapping Lab, NOAA, and other partners. And so there's a number of challenges in dealing with these large bathymetric data sets. And so one main challenge is vertical datum, conversion and functionality. So currently, USGS is using the NGS Geodetic Toolkit, which is served online at NGS to convert their vertical datum. And so if this was accomplished within ArcGIS, that would be a great step. So the opportunity is really having a vertical datum standard and conversion built in. Next, there's challenges with 3D visualization. And there's limited 3D rendering capabilities and functionality within the software now. There's been some recent advances. However, with the raster catalog and mosaic datasets tools, but there's opportunities for further improvement and refinement of these 3D rendering capabilities in ArcMap. And some additional improvements could be including interactive hill shading and profiling with bathymetric data, and also enhancing raster data symbolization, both in 2D and 3D. And again, managing and processing these large bathymetric data sets is always a challenge. So there's been recent advancement with the release of a new extension in 10.1, the ArcGIS for Maritime Bathymetry extension that Dawn talked about earlier. And so that's helpful in managing these data sets, and there's further opportunities for improvement on this particular extension to expand from working solely with bags data to include ArcGIS grid format and other data file formats. And then also to support data processing with other tools and extensions that are used to derive useful metrics or create habitat maps from this bathymetric data. Dawn brought up the recent update of the benthic terrain modeler. This has been a really useful tool for deriving and driving metrics and habitat mapping from bathymetric data sets. It's been recently updated to ArcGIS 10, and there's some enhanced metrics that are included in this tool, such as the vector ruggedness measure and curvature. So there's opportunities to include additional metrics and also to allow for more of a multi-scaled approach. Right now the tool allows you to derive metrics at one spatial scale, and so in order to apply more of a marine landscape ecology approach, it would be useful to be able to derive metrics at multiple spatial scales. And then also to streamline this process with other tools and extensions. So just to summarize and hit on the main points that we received as feedback from our user group, we need more support with the 3D and 4D geoprocessing, visualization, and mapping in order to capture really the dynamic nature of our data sets and the ocean in GIS. And we need increased capabilities for distributing these maps, these dynamic maps, more in real time to help support things such as the marine spatial planning or dynamic ocean management. The vertical datum and standard conversion is going to be a really important step forward, especially when working with nearshore LiDAR data, when merging terrain and bathymetric LiDAR data in that nearshore environment. That's really where centimeters matter, and this is an important step. And finally, we need to think about and integrate human dimensions data sets within our database model and our general conversations here. So just to conclude, the way we view the ocean really determines how we manage it. And so by advancing marine GIS tools and applications, it will help us to facilitate mapping, identifying, and placing value on heterogeneity at sea. And mapping and identifying this heterogeneity is really important because it allows us to see value in spatially discrete locations in the marine environment, and that is the provides the fundamental rationale for all these forms of marine spatial management. Okay, thank you.